Good morning, dear students. With you today, your science teacher, Miss Salma, and we're here to cover Unit 1, Lesson 3, Atomic Structure of Matter. We'll move to slide 2. What is the structure of an atom? The matter, any matter, is consisted of molecules, and molecules are consisted from atoms. What are the atoms? Atoms is the fundamental building unit of matter, or it's the smallest unit of the matter that can share in chemical reaction. Slide 3. In this table, the chemical symbols of some elements. As we see, we have the hydrogen represented by H, and chlorine represented by Cl, helium is represented by He, argon is represented by Ar, and so on. Slide 4. The symbol of the element is represented by one letter or two letters. One letter is always written in capital. Example, carbon. The carbon symbol is represented by the letter C. Two letters. The first letter is always written in capital, and the second letter is written in small. Example, sodium, Na. The letter N is written in capital letter, and A is written in small letter. Slide 5. Some elements are common in their letters, so the second letter is taken to differentiate between them, like the carbon and the calcium. Both of them are started with letter C, so we take the letter C for carbon and Ca for calcium. A is to differentiate between carbon and calcium. And hydrogen and helium. Hydrogen and helium are started with letter H. So we take the letter E, written in small, to differentiate between the hydrogen and helium. And so on in sulfur and silicon. Sulfur is written only S, and silicon is written Si. And we have some elements differ from their names in English because the element symbol is derived from its Latin name. Like sodium. Sodium is started with S, but its symbol is Na. Na is taken from natrium, its Latin name. Natrium started with Na. Potassium, its Latin name is kalium, and it started with K, so its symbol is K. Iron, its Latin name is ferrum, and it started with Fe. Copper, its Latin name is coperium, Cu. Silver, its Latin name is argentum, and its symbol is Ag. Slide 6. The atomic construction. The atom is consisted of two particles, the nucleus and the electrons. The nucleus is located in the central core of the atom, and any nucleus contains two particles, protons, and it's positively charges with it's positively charges particles, and neutrons. It's electrically neutral particles, uncharged. So the nucleus is positively charged because it contains the proton with positive charge. The mass of the atom is concentrated in the nucleus. Second particle is electron. Electrons, they are a very small particles. They orbit or revolve around the nucleus. It revolves at a very high speed around the nucleus. They are negatively charged particles. Their number equals the number of the positive proton in the nucleus. They have a negligible mass relative to the mass of protons and neutrons. So we can say that the mass of the atom is concentrated in the nucleus. Slide 7. To express any element, we use two terms, which are mass number and atomic number. As we see in the picture, we have the aluminium symbol, Al. It has two numbers, 27 above the symbol and 13 under the symbol. 27 is a big number and 13 is smaller than 27. So 27 is called the mass number, and it's the sum of the numbers of protons and neutrons in the nucleus of an atom, written above the symbol at the left side. And the atomic number, it's the number of the protons or the electrons of the atom, and it's written below the symbol at the left side. We have some questions. What is meant by the atomic number of calcium atom is 20 This means that the number of protons or electrons in calcium atom is 20. The mass number of calcium atom is 40. This means that the sum of protons plus neutrons in calcium atom is 40. Slide 8. From all the previous explanation, we conclude that atomic number equal number of protons, also equal number of electrons. Mass number equal number of proton plus number of neutrons. Number of neutrons equal mass number minus atomic number. The movement of electrons around the nucleus. We have a small activity to imagine the movement of electrons around the nucleus. Bring a turned off electric fan and look at it. You can see it obviously. Turn on the fan to make it rotate. Observation. You can see the arms clearly when it turned off, but when it rotates, we can see the arms as a cloud around the center of the fan. Conclusion. Electrons are like the arms of the fan, where during the movement of electrons, they seem to be a cloud around the nucleus. Electrons revolve around the nucleus at a very high speed in a number of shells called energy levels. Slide 9. Energy levels. What are the energy levels? Energy levels are imaginary regions or places around the nucleus in which the electrons move according to their energy. The maximum number of energy levels in the heaviest or largest atoms is 7. Now we'll talk about the arranging of energy levels. Energy levels are arranged according to their nearer to the nucleus from inside to outside as follows. We have the stable and we have level symbol and level number or order. The K level L, M, N, O, P, Q, 7 levels. Each level has a certain amount of energy that increases by increasing the distance from the nucleus. That means that the first energy level K has the least energy and the seventh energy level Q has the highest energy. The energy level L is greater than the energy level K and is also smaller than the level M, and so on. Slide 10. We'll talk about transferring of electrons from one energy level to another. The energy of electron depends on the energy of the level that revolves in, where the energy of the electron equals the energy of the level that revolves in. The electron cannot transfer from one level to a higher unless it gains some energy equals the difference between the two energy levels. This amount of energy is called quantum. So the quantum is the amount of energy that lost or gained by an electron when it transfers from one energy level to another. And the excited atom it's the atom that gains or lost a quantum of energy. Slide 11. What happens if the electron gains a quantum of energy? It will transfer from its energy level to a higher energy level, and its atom will be an excited atom. Number 2, the electron in the excited atom loses a quantum of energy. It returns to its original energy level, and the atom returns to its ground state, as shown in this picture. Slide 12. Electronic distribution or configuration. Each energy level can take a definite number of electrons. These electrons are distributed in the first K level, the least energy, then second, and so on. The number of electrons which saturates the first 4 energy levels can be calculated from the relation to n power 2, where n is the number or the order of the level. We can see it in this table. The level symbol K, its number is 1, and according to the relation to n power 2, it's saturated by 2 electrons. While the L level, its order is 2, and it's saturated by 8 electrons. While M, its order is 3, and it's saturated by 18 electrons. N level, its order is 4, and it's saturated by 32 electrons. we can see that the outermost energy level of any atom in any atom can take more than 8 electrons, except K level. It's saturated by only 2 electrons. Slide 13. Electronic configuration and the chemical activity. We have two types of atoms. We have active atoms and inactive atoms. Inactive atoms, their outermost energy level is saturated less than 8 electrons, while the inactive element, its outermost energy level is completely filled with 8 electrons, except helium that is completely filled with 2 electrons only. Atoms of active elements unstable. They take part in chemical reaction, give reason to produce a stable molecule. We have an example, sodium atom. We can distribute the 11 number by 2, 8, 1. We can see that the M level only have 1 electron, less than 8 electrons. So the M level is not completely filled with 8 electrons. While in atoms of inactive elements, they are stable, don't take part in chemical reaction because their outermost energy level is saturated by 8 electrons, except helium, as we said before. Example, the argon atom, its atomic number is 18 and it configured by 2, 8, 8. We can notice that M level is completely filled by 8 electrons. Slide 14, some questions on lesson 3. Give reason. The atom is electrically neutral. Why? Because the number of positive protons inside the nucleus equals the number of negative electrons that revolves around the nucleus. Number 2, the mass number is always higher than the atomic number because the mass number is equal the sum of neutrons and the protons, while the atomic number is only equal the number of protons. Write the scientific term. Positively charged particles in the nucleus, protons. Neutral particles in the nucleus, neutrons. The number of negative electrons or positive protons. It's the atomic number. Thank you for listening and see you soon.